All right, so we're still on our 6-3 notes. We're jumping to example 2. And in example 2, we're still working with linear functions, but this time we're going to be analyzing a graph. Now, this is the type of question that you guys are probably going to see on the PSAT or the SAT, where you're given a graph and you have to analyze the information. So students in the 9th grade class drew the following graph to represent how much money would be in the class fund after selling sets of photos of their year's activities. So anytime you're interpreting a graph, you should always check out your labels. So I see that I've got on my x-axis the number of sets of photos, and on my y-axis I've got money. So what's happening as I sell more sets of photos? I'm making more money, right? My graph is increasing, and so I'm making more money as I sell more photos. Whoops. So question A says, what does the slope and the y-intercept of the graph mean for the given situation? Let's go ahead and start with the y-intercept. My y-intercept looks like it's about here at about like what, $22? Who thinks they could raise their hand and tell me what does that represent? $22 means what? What does $22 mean? Very good. That means they're starting with $22. So what that means is the 9th grade class is starting with about $22. That's how much money they currently have in their fund, $22. Now the slope is the rise. So it looks like I'm rising up from 22 to just under 40. So what is that, about 18? 22, yeah, just under 40, so like 16 maybe. Yeah. So I'm rising up 16 and I'm going over 1. Up 16 over 1. So if I go up 16 over 1, up 16 over 1, up 16 over 1, up 16 over 1. Who thinks they could raise their hand and tell me what the slope means? What does that mean, 16 over 1? What's that? That's my rise over run. Good. Now, who can describe that using these labels here? We're rising up 16 what? We're rising up $16 for every set of photos, for every one set. So basically, you make $16 or about 16. That's an about symbol. You make about $16 per photo set. That's what the slope means if you're interpreting the slope. $16 per photo set. Now letter B says, if the graph had the same slope but a y-intercept of 40, what could you conclude? So, what's that? Okay, you'd have more money in the end. Why? Very good. You're starting with more money, therefore you're going to have more money in the end, right? So when it says what could you conclude, you could say starting with more money means you end with more money. So our graph is basically just going to start up higher, but the slope is going to be about the same. It's still going to increase at the same rate as what it was before. And we're going to end up with more money in the long run because we started with more money. And then let's take a look at letter C. Letter C says, if the graph had a slope of 12.5, what could you conclude? So this time we're still got the same y-intercept, but my slope is 12.5 instead of 16. So who thinks they could raise their hand and tell me what can you conclude from that information? Very good. All right, so you're only going to make, let's see, you make $12.50. So I'm going to do $12.50 per photo set. So what else can you conclude from that? That's exactly right. Instead of making $16, you're only making $12.50. Yeah, very good. You're going to be making less money, right? So you're making $12.50 per photo set. So you will make less money. Any questions on that? Are you okay? That's a really good observation, actually. Not one that I thought about. What he's saying is, in the long run, you could end up making more money because he's saying that more people might be willing to pay $12.50 as opposed to 16. So in different scenarios, yes, it could mean slightly different things. All right, go ahead and flip to this last page, and I want you to try this one on your own. And then we'll go over these in just a moment, and then homework. Do you guys know what the word altitude means? It means how high something is. Yeah, very good. If it says the graph shows the altitude, that's just the height of the helicopter. Well, you don't necessarily have to find the slope. It just wants to know, what does the slope and the y-intercept reveal? So you might not have to say what the slope is. You just have to describe what it means. And actually, well, I would probably use this point right here and then this point right here. So if you want to calculate the slope, I would use these points. How much is it going up by on your y-axis? 100. Oop, just keep it in your head. Keep it in your head and write it down. So if you're going to find the slope, I would use those 2 points right there. All right, so I personally typically like to start with the y-intercept. So who thinks they could raise their hand and tell me what the y-intercept means? What does the y-intercept represent in this situation? Very good. All right, the feet above ground it starts at. Anybody have a guess why a helicopter would start at 200 feet above ground? Good. It's like on a helipad. If you think about like a hospital, their helicopters start on a helipad. So that helicopter starting 200 feet above the ground. And then who can tell me what the slope represents? You didn't actually have to calculate the slope if you didn't want to, but what does the slope show up? Very good. All right. It tells us the height of the helicopter over time. So as time passes, how high is that helicopter is what it tells us. Letter B says for a similar situation, the slope is 85 and the y-intercept is 250. What can you conclude? How many of you guys actually started drawing on your graph to draw another one? Because that's what I would have done. In order to compare these, I would go up to my graph. I would start at 250. So this is starting at 200. I'm starting at 250. And I have to go up 85 and over 1. So let's see, 250 plus 85 will give me about 335. So I'm going to go right about here and go over to 1. Oh, no, I'm not at 1, am I? Now I am. And then if I add 85 again, I get 420. So I'm going to go just above 400 and go over to 2. And then if I add 85 again, I'd be at just over 500. Go over to 3. So what are you noticing? It's going higher, right? It's increasing at a much, much greater rate, it looks like, doesn't it? Kind of does. If we take a look at the original slope, it started at 200, went up to 300, so it increased by 100 over 2 minutes. So what does that simplify to? 50, right? So can you see how this is a much steeper slope? So what's going to happen to that second helicopter? Yeah, it's going to rise a lot faster. Yep, it will rise a lot faster. Or something to that effect. It's going to increase at a greater rate, or it's going to get to its final height a lot faster, something to that effect. All right, I want you guys to grab out your homework, which is the 6-3 worksheet. Let's see, probably. So you guys are going to want graph paper, and I would recommend using just the graph paper that just has the grid, doesn't have the actual. You just want this stuff with this grid in the background. Or you can make your own if you would like to. That would be fine on an assignment like this. Yep. All right. So for homework tonight on the 6-3 worksheet, so on the 6-3 worksheet, you're doing 1, 3, 4, and 6. You do need to graph those. So you can either make your own graph paper on a sheet of line paper or grab some graph paper. And then 7 and 8, you're interpreting.